So to start today, I would like you guys to list 10 things that are made out of petroleum-based substances. If you've already done that, just go ahead and keep listening, and if you have not done that, then go ahead and pause the video while you do that. Hopefully you guys came up with items that are plastics. Maybe you came up with some of the materials listed here: polyesters, nylon, acrylic. Maybe you listed specific things like your polyester or nylon backpack or your shirt, or maybe you came up with plastics like a plastic bottle, or maybe your folder is made of plastic, or you're writing with a pencil that has a plastic casing on it. Maybe a grocery bag. Right here you see a substance called Bakelite. Bakelite was one of the first plastics ever made. They used it mainly to make bracelets and jewelry out of. The problem was when it got a little bit warm, it had this nasty sulfury smell to it. Maybe you listed rubber like a tire. Maybe you have like a coating, a plastic coating or a laminate on a poster or a folder. That would also count. But if you look over here in this area, we have natural polymers. DNA, RNA, proteins, cellulose, silk, wool, gelatin, all of those things are also polymers as well. So hopefully you made a good list of polymers that you had made. Today's topic is petrochemicals, and petrochemicals are petroleum-based chemicals. If you remember our last chapter, Petroleum B, talked about burning with petroleum. So you guys learned about calories, kilocalories, joules, those are energy units. You also looked at the combustion reaction, balanced combustion reactions. You also, well, that's about it. You focused on combustion and the energy units. Well, this chapter here is about building with petroleum. So we're going to be talking mainly about alkenes, alkanes. You're going to learn about something called aromatics. But we're going to talk about what we can build with petroleum molecules rather than burn. First of all, we need to talk about the building blocks that make up petrochemicals. Those are monomers. Monomers are simple molecules that get linked end to end to end to end to end and make these repeating units called poly. So the prefix mono means one, and the prefix poly means many. You've probably talked about that in a geometry class, like a polygon. A polygon has many sides. A polymer is made up of many mers, or single units that are linked together end to end to end. So, for example, a bowling ball. A bowling ball is made out of a polymer. So it's many monomers that are linked one end to end to end to end to end. And a bowling ball then is actually one molecule because those monomers are just linked together and wound together and turned into a ball. When we link those monomers together, we end up making a polymer, like I just said, and that process of putting them all together is called polymerization. So polymerization is the process of linking monomers together. We're going to go through a brief history here before we had polymers, because plastics were not always around. Until the early 1800s, humans basically used whatever it was that they found in nature to make materials out of. So clothing would have made out of leather, which is animal hides. Building materials were lumber that came from trees. A fire was done with lumber. So mostly we used things that would just be found in nature. Some of these natural products were wood or stone, metals, mostly metals that didn't require chemistry, so things like gold and silver that are not very reactive. Glass, clay. Clay is, it's a type of soil basically. Cotton fibers from the cotton plants, wool from sheep, linen, silk. All of these things are natural fibers that we can weave into fabrics. And then natural polymers are things like wood and shellac. Shellac is a shiny paint that you would put over wood to kind of seal it. And that shellac actually comes from the exoskeletons of beetles. Today, most of what we wear and use in our lives is made out of synthetic material. It's created by chemistry, polymers, plastics. Okay, all of those things have to be manufactured. If you look over here, we've got nylon, we've got Dacron, we've got rayon. All of those are synthetic fibers, synthetic polymers that we manufacture clothing and backpacks and a variety of things. The title of this slide, or the title of this PowerPoint, was Petrochemicals. Petrochemicals are substances that come from petroleum or natural gas. So a petrochemical is going to take a monomer that's a petroleum-based substance, and we're going to polymerize that. Maybe some of these are substances you listed at the beginning, where you listed your 10 petroleum-based chemicals, but we've got detergents, pesticides, pharmaceuticals, cosmetics, plastics, fabrics, rubber, paints, foams, and adhesives. Rubber is in quotes here because you can have natural rubber from the rubber tree, or you can have synthetic rubber. And so here we're going to be talking about the petroleum-based rubber. Just a little fact here about how much we use plastic. Petrochemicals are more than 4 times the quantity of aluminum products that we use. As I stated earlier in this presentation, petroleum has 2 uses. We burn it, and that was in our last chapter, or we build with it, and that's what we're going to be talking about in this chapter. So I realize we have a little overlap in the text here. The 2 most important builder molecules are ethene. In the formula for ethene, it's kind of jumbled up here. It would be C.2H4. Notice the eth here, the root means 2, which you see over here, the C2H4, and the ene tells you that there's a double bond. So 1 carbon, 2 carbon, the double bond, ethene. Ethene is a monomer that we're going to link end to end to end to end. Our second builder molecule is propene. Prop means 3, so 1, 2, 3 carbons. Ene tells you that there's a double bond. So our formula again is C3H6 for this, and this is our second most important monomer. On this slide, you can see how ethene would react with water to form ethanol. Now, ethanol is not a polymer. I'm just showing you here how the ethene, right here, this is my ethene, is going to react with the water, and we're going to get ethanol out of this. Notice that the double bond, there used to be a double bond here, the double bond now becomes a single bond. This is called an addition reaction because the double bond is removed by the addition of water. By definition, addition reactions occur at the double or triple bond, and they're a result of adding hydrogen. So by addition polymerization, ethene can link end to end to end to end. So I'm breaking this double bond that you see right here. No more double bond, which opens up places to add substances. So if I link ethene to ethene to ethene to ethene, I end up with poly, remember, which means many, ethylene. I've removed that double bond, but because it used to be there, we're going to link it end to end and call it polyethylene. So if I stick, here's a monomer, here's a monomer. If I stick 2 of them together, di means 2. If I stick 3 of them together, tri means 3. And then down here you can see I stick a whole bunch of monomers together, and therefore we call it a polymer. Polyethylene was the example that I just gave you. Poly, many, eth, 2, ene, and it broke that double bond. So polyethylene is what we use to make shopping bags, bottles, and toys. We're going to go through several addition polymers now. Our second addition polymer would be saran wrap. Polypropylene, which is kind of a more rigid plastic that you might find in a folder or a binder. Another one is PVC, PVC pipe. You might have PVC pipe in your homes. They make chairs now out of PVC. Polyvinyl chloride. The next one's polystyrene. This is a styrofoam. What I do want you to take note of right here, this is called a benzene ring. It's an aromatic compound that we're going to talk about in our next lecture. Other addition polymers, Teflon, that stuff that makes your pans stick. Plexiglass is an addition. We can change how rigid or how flexible a polymer is by adding lubricants. So if you add lubricants, you're going to make a rubber band more stretchy. You're going to have Lycra. You can have spandex. So the more lubricating molecules you add, the more stretchy or flexible your becomes. Then we can make it more rigid by increasing what we call cross-linked chains. And so tires, we want them to be very rigid. We increase the cross-linking. So the cross-linking are these red squiggly lines that you see linking the polymers together. The next group of polymers are called condensation polymers. So everything I talked about before this was addition polymers. So we added water. In a condensation polymer, we're going to have, right here you see it, a loss of water. So water is going to be on the product side of that reaction. So what does this look like? Condensation polymers, we have an alcohol. Here's my alcohol. We have a carboxylic acid. This right here, this guy's a carboxylic acid. Here's an ester. That's my product. Esters have a fragrance. That's why there's a little skunk here. And then out of this comes water. And so this is condensation polymer because water is a product. And we rearrange the bonds here to produce our ester. Now, this equation down here does not make a lot of sense to you because we haven't learned about alcohols, carboxylic acids, esters, and ethers. That's going to be coming up in our chapter. But the main idea here is that a condensation polymer produces water. And now we have some examples of condensation polymers. Natural polymers such as protein, starch, cellulose. We also have nylon, which is a man-made material meant to replace. Polyester is a very common condensator. And then PETE, P-E-T-E, polyethylene terephthalate. This is used in your soda bottles or your water is PETE. So when you look at the bottom of a plastic substance, there's always these recycling codes, 1, 2, 3, 4, 5, 6, 7. Well, what does that mean? That actually describes the type of plastic that it's made out of. So the recycling code of 1 is PETE, polyethylene terephthalate. You just saw that on the last slide. The next one is high-density polyethylene, milk containers, PVC, polyvinyl chloride, LDPE, low-density polyethylene, polypropylene, polystyrene, and then other. So when you go to recycle something, we just throw all of our plastics in a container together. At a recycling sorting facility, then, all of these materials would get sorted by number. So all of the 1s would get recycled together. All the 2s would get recycled together. One of the cool things that's happening with these number 2s, they're using this high-density polyethylene. When they recycle them, then they'll make fleece jackets. Like Patagonia jackets are made completely of recycled soda bottles and milk bottles. The next couple slides, there's nothing to write in your notes. That's just going to show you a couple monomers and how complex they can actually be. Again, this is that ring we're going to talk about in our next set of notes. So this is polyurethane. So this would link to another molecule that looks just like this, and same thing over here. So this is the monomer that's going to get repeated. Here we have the spandex monomer, even more complex. So this right here is the monomer that will link to itself here and link to itself over here on the opposite side. Then we have nylon. Here is that monomer for nylon that's going to link over here on the right and the left-hand side. And then lastly, this is polyacrylate, the monomer. Again, here's the monomer, and then here are those empty spots for the polyacrylate to bond one right after another. So hopefully you guys finished your notes. And we talked about what a petrochemical is, examples of petrochemicals. We talked about the difference between an addition polymerization and condensation polymerization. And then we talked about some different monomers here at the end.